All right, this from Robert Morris. You don't know Robert Morris. He's one of the signers for the Declaration of Independence. He was from Philadelphia, well, Pennsylvania. I think he was from Philadelphia. He was known as the financier of the American Revolution. Wealthy businessman. He was the chair of the Finance Committee of the Second Continental Congress. It was his responsibility to raise money to fight a war with Great Britain. Tell me, what do you think? Is like buying bonds from the Second Continental Congress in 1777 a pretty good investment, or would that be a pretty bad investment? Yeah, what's the likelihood of you getting paid if they lose the war? Yeah, 0. What's the likelihood of them losing the war? Really, really high. And even if they won the war, they don't even have taxing authority. How are they going to pay you back? Anyway, it's tough to get people to give money to the Second Continental Congress, even to loan money to the Congress. So he kind of time after time, he goes to folks he knows, wealthy folks, we need you to loan money. And they say, we're not giving any money to the Congress, but we trust you, Robert. We'll loan money to you. And on his personal credit, he essentially financed years of the war. Normally, when we hear about Robert Morris, we kind of jump to the end of his life and he died as a pauper. He really did. He died poor. But it wasn't because he lent all of his money to the Congress. He recovered from that okay. He will become a real estate investor and do very badly in the market. That's how he ends up losing all his money. But anyway, he's kind of talking about kind of the feeling of our founders at the time of the founding with regard to religion. He says, religion is the solid basis of good morals. Therefore, education should teach the precepts of religion and the duties of man towards God. And we used to do that. I mean, even into maybe the middle of the 1900s, that was pretty regular to have kind of religious things taught in classrooms all over the country. And we don't do it anymore. Anyway, I think we've lost something. Okay. I hope you had a great week last week. Seems like a long time since I've seen you. Let's go ahead and get files downloaded for today. So we're on, if we go to the blog for the course, the loops and repeating actions, the unemployment.xlsm file here to download. So today we're really talking about loops. And we're going to talk about the 3 main kinds of loops that we have in VBA. And of course, a loop is just something that allows us to repeat code over and over again. And there's kind of different ways to tell it how many times or over what set we're going to repeat. I'm not sure why the microphone is kind of giving that popping. Is it terribly distracting when it pops? Are we okay? Not too bad. Maybe I'll try to talk softer. I don't know. All right. So this file, I think when I built this file, we were actually going to go and pull information for each one of these. So this is the like for getting census information. So here's Alabama. Alabama, the whole state of Alabama for doing census information is number 1,000, and then each of the counties in Alabama kind of come under the 1,000 number. So Baldwin County is 1,003. Barber County is 1,005. Why they're all the counties are odd numbers? I don't know. Maybe they're saying the counties in Alabama are odd. I don't know. But it looks like they're all odd, so I don't know. In fact, why don't we just go ahead and, is the mic still? Can you still hear me through the mic? Or did the mic just die? Is my voice coming through the microphone? Yeah, it is. Huh. All right. Oh, thank you, Sarah, on Zoom. Okay, but let's just take a look at the code that we have here, just because it might be interesting code to you. So if I come and look at module 1, well, let's take a look at this module called web query. So you may remember that you may remember that the web query is kind of now in legacy mode. You can't get to it through the menu. You've got to search for the legacy web query and pull it up. So, but I did create this function called create web query, which will create a legacy web query. So you can actually build a web query just by running this code. You don't have to use the tool to create it. So I don't think we're going to be using this in class today just because it takes a while to bring in this information. And so it's not really worth waiting for. But that's code here that may be interesting to you for other reasons. Why that's so wide, I'm not sure. There we go. Okay, so module 1 then is just going to use, this is an example of actually calling that create web query function. And it's, what are we doing here? Create a sheet to hold the data. So we're making a new worksheet. And then we are going to be placing the data from the create web query onto that, onto beginning in cell 1 of that sheet. So this actually does something that we haven't seen yet before, and it shows you what these parentheses are for. So you can imagine I've got this general procedure import county data, but I want to be able to import lots of different data from lots of different counties. And so by setting up a variable, and we'll talk about this more later in class, just happens to show up in this example. By declaring a variable inside those parentheses, when we create the subprocedure, I can then give that variable a value when I call the subprocedure. So here I'm calling that subprocedure import county data, and then I'm giving it this county 20063. That value will come into this variable FIPS. And so when I use FIPS down here below to build the URL for this web query, then that's the value that will come in. So this is a variable. It's a special variable called the parameter. It's declared inside these parentheses. You don't use the keyword dim. It's the only thing you can do in those parentheses. But it lets us create a subprocedure that's kind of general use, and then giving it its kind of specific information each time it runs, each time we call it. Just kind of show me on a scale of 0 to 5, 0. I have no idea what you just said, Professor Allen. 5, we totally got it. How you feel about that idea of declaring a variable inside the parentheses there. Seeing 5, put your hands down if you learned this passing parameter somewhere else. This is a new idea to you. We're seeing, okay, so you're saying brand new and you still feel comfortable? Yeah, okay, good. Okay, and we'll do more with this so you'll get comfortable with it. Anyway, so just for kicks, I'm going to go ahead and run this one, and it will then create the web query and bring in the information for my very favorite county in the whole nation, county number 20,063. It's Gov County, Kansas. That's where my name came from. And again, I think I put all this code into this workbook thinking it would be kind of fun to actually pull this data, in a loop during class, but it ends up taking longer to run the code than we're going to do in class. So we'll just kind of look at some general examples using loops here. Okay. Any questions on that existing code before we kind of get into the loops for today? All right. I'm going to go ahead and insert a new module here, and we'll just kind of work in a clean module. So insert module. And let's take a look a little more specifically at the do loop. So we've done a few examples with the do loop. We've even got a project that's due on Wednesday that I'm expecting you to use the do loop for. But let's take a look at it in a little more detail. Okay, so I'm just gonna make a loop here that's going to only display as long as we're looking at Alabama. So let me come in here and say, get a few things set up here. Let me dim row as a long integer. Someone really quickly just tell me the range for a long integer, plus or minus. Actually, I don't want long. It's 2 billion. I don't want long. I want integer. No, I do want long. Plus or minus 2 billion. If I'm just referring to rows, why not use integer? What I need this variable to kind of be able to look at all the rows where we have data here. And there's 3,274 rows with data. So what do you think? Should I use the integer data type here to have a variable that's going to kind of keep track of which row I'm on? would the variable data type work? What's the range for, would the integer data type work? Yeah, what's the range? Yeah, it's like 32,000. It's got like 10 times as much as I need here. But I prefer to use long anytime I'm referring to a row. And the reason is that if when I'm referring to a row, I always use long, I don't have to worry about ever running out of space in the variable to refer to a row. So if I'm working on something and I'm not sure how much data there's going to be, and maybe they're going to add more data in, it costs me 2 bytes to go from a 2-byte integer to a 4-byte long to be sure I'm never going to run out of space. That's worth 2 bytes to me. How many bytes do I have? Billions. I have billions of them just waiting to be used. So I'm going to use long here. Okay, and then let's set this. I'm going to initialize this at the first state that the first row that has Alabama on it. So that's going to be row number 2. So let's give it a value row equals 2. Remember the do loop. Just that sets up an endless loop. So don't run this yet. In fact, anytime I create a do loop, I think it's always a good idea to put do events. Someone just quickly tell me what do events does. Do events inside of a loop just says, hey, at this moment, just kind of pause for a second and check to see if anything else is trying to happen here in Excel. And so if I have a do events in there and I'm trying to break into it, like clicking the stop or the pause buttons up here, then that do events is going to say, oh yeah, he's pressed the stop button, let's stop. Without that, our little VBA interpreter here puts his head down and runs this loop so fast that you can't get his attention. And if you accidentally put yourself in an endless loop, hope you have saved your workbook, because you're not going to be able to save. Or hope that your autosave has happened, pretty recently. Okay, so now I want to, before I kind of do what I'm going to have this loop do, I would like to actually control it. So let me go ahead and increment row in here. Row equals row plus 1. And I'm going to let's do it down here. I'm going to loop until, and then looking at this sheet, let's just for now assume that we're going to be on the active sheet. So I won't spell out the sheet that I'm on. Actually, I will. So you can see, I'm just going to show you a different way to refer to it. One way to refer to this would be able to say worksheets. And the name of the worksheet is counties. COUNTIES. Right, this says in the active workbook, out of all of the sheets, worksheets, there's one called counties. This is a little bit dangerous to do in your code. Why? Why is it dangerous to refer to a sheet this way in code? Yeah, your user might come in here and say, that shouldn't be called counties, it should be called data. And as soon as the user does that, this code breaks. So, but you'll notice that up here, let me zoom in here, Windows Plus. So up here is, it's showing me, there's that sheet I just renamed to data. In parentheses, I see the name that's on a tab, but it's got this other name right here before the parentheses, and that is the static name of that sheet. I can refer to it by that name without having to worry about the user changing it. Well, the user could come into VBA and change it here, but as soon as someone opens up VBA and makes changes, we're going to have to believe that that's something we're not going to prevent from happening. So that's not a normal thing. Go back. There we go. And so instead of referring to it that way, I'm going to refer to it just as, what was the name? It was county by its singular. So just the bare label like that will refer to that particular sheet. Cells. Now the cells method allows me to look at a particular cell. I'm looking at, right, if I was looking at row number 1, column number 3, could do it that way. Or I could look at it row, column number 2. And actually, I'm going to execute this while looking at the county sheet, whatever row I'm on, column 2 is equal to Alabama or AL. Now I just have to do something interesting inside the loop. So now I've got my loop set up. I've got do events in here. Just because the do loop is pretty easy to accidentally put myself into an endless loop, always a good idea. Now let's just do something. All I'm going to do is debug.print. I think initially I thought it might be fun to actually call import county data, but we'll do that and it will take forever. So debug.print, and let's just print out the value that we're looking at. I'll pull the values from column 3. And that should do something interesting. What was a good idea to save just before you run something, especially while you're learning loops, just in case we've done something wrong that causes the whole Excel to lock up? Looks pretty good. I got down to Winston County, Alabama. And if I scroll down, is that my last one? Yeah, that's my last one. So I feel pretty good about that. Okay, any questions just on the basic format? We got some things to change about here, but any questions on the basic format of the loop? Okay, so instead of while, so the condition while says we are going to execute while this condition is true. I can do an until, which says I'm going to execute until it's true, or as long as this condition is false. And I'll change this to Alaska, and that should give us something really similar. I'm going to continue to execute until this is true. And so until we get to Alaska, we should be in good shape. So that gives us just the ones in Alabama as well. So you can either do, you can loop until or loop while. You can also put the exit condition up at the top. And so that should do exactly the same thing. What's the difference about putting it at the top or the bottom? There's one slight difference. Yep. That's exactly right. So if I put it up here, if the exit condition is here, if that exit condition tells me to exit, if it's at the top of the loop, I never run the code inside the loop. So if I'm going to do while, this is Alaska. So on row 2, the state is Alabama. So this is going to be false. So do while false is going to exit. This is not going to print anything. But if I put this at the bottom, it never checks that exit condition until it's gone through the data once. So I should get the very first line. That is the only difference. It's tempting to think, oh, if you put it at the top versus the bottom, it's going to run one more time or one less time. But realize that these two segments in the code are right next to each other. Because what is the next thing that executes after loop? It goes right back up here to the do. The next thing that happens is do. So the only difference is it guaranteed to go through the code once? So that's really the big difference for do until, or for the do loop. Okay, I'm going to make a little modification on this to say what I want to do is execute a fixed number of times. So now I'm not going to be looking down here at kind of going back out to the worksheet to see when I should be done. I'm just going to say, listen, I want to execute 17 times. So let's go ahead and do that. I'm going to show you how we would do that with the do loop. And then we're going to modify it and see like the loop that's really built in and meant for this. So instead of R, let me just call this X. It's a great name for a variable X, just some value. Now, instead of starting at 2, I'm going to start at 1. And now I'm going to do until X is greater than, shall we say 10? UNTIL. I'm going to count X on the inside of this. And now instead of row, I'm going to do X plus 1. If I just did X, it would start off by printing the header, which I don't really want in this case. I just want to print the county names of the first. Actually, let's do, yeah, we're going to do the first. We're going to print off 10. In fact, I'm also going to print X1 here. Okay, so now it should print 1, and then Alabama should then print 2, and Antigua, and so forth. We'll run this, and it looks like I've printed off those 10. Executed 10 times. I maybe thought it was going to go 11 times since I'm going till it's greater than 10. Kind of tempting to think that, but remember, as soon as we go greater than 10, as soon as X is going to go greater than 10, before we print again, this is going to let us out of the loop. It turns out that it is so common to want to iterate across a range of an integer value that there's a whole loop built for it. And let's take a look at that one. This is called the for loop. Whoops, not dim, but sub. Okay, so the for loop, we're going to do exactly the same thing that we did here with the do loop in this context. I'll declare X as a variable, but then I'm just going to use the for loop. For X equals 1, 2, 10. Next. And here I'll go ahead and do the same debug.print statement on the inside. So the point here is that because this idea of saying I want to iterate once as I'm changing the value of an integer is so common a need, they built a loop specifically for doing it. You'll notice that I don't have to have a line like this to tell X to increment. The loop does that automatically. So this loop is saying, all right, I'm expecting you to give me an integer variable right here. You're going to tell me its starting value. Check a look at this. What if I say X equals 20 to start with? So I'm going to comment that out. Before we do that, let's see that it works okay the way it is. Does those first 10 just fine. Now, what's going to happen if I set X out of bounds? X is now not going to be inside that range 1 to 20. What are we going to do? What's going to happen? Let's vote. How many of you say it's not going to print anything? How many of you say, no, it's going to print the same thing it did before? It's going to print the same thing, because the interesting thing is that this statement right here, this X equals 1, initializes X. It sets X to that starting value. And then it's going to add 1 to it each time. So we'll run that. And this is the for loop demo. So that's kind of an important thing to understand about this, is that it's actually setting, it's changing. The very first thing it does, it changes X to that initial value. It does not matter what X was before it. By the way, what am I going to print if I get an X, if I print X out here? This is either going to print 0, 1, 10, 11, or 20. That'd be a great multiple choice question on a test. Who says it's going to print 0? Anyone else going to go with 1? We're going to reset it to the beginning value. How about 10? Value that it ends on. How about 11? A couple of saying 11. How about 20? No one's going for 20. It's actually going to print 11. Let's take a look. It's not going to print anything. Oh, I put it outside of the end sub. Put it inside the end sub, outside the loop. Oh yeah, well now, if you had put it there, we would have said 11 from the beginning. The reason that this loop stops executing is because X goes out of bounds. And so we get to this next, and that's going to increment X. In fact, it's optional, you don't have to do it, but you can put X here. And that's helpful if you've got like several nesting levels of 4 next loops. But when we say next X, it's going to change that value. It's going to come back up to the top and check to see if it's still in range. If it's still in this range, 1 to 10, it's going to continue to execute. So think about the last one that happens here. X was 10. We printed X equal to 10. We got to the next X. It incremented X, pushed it to 11, came back to the top of the loop and says, oh, we're out of bounds. We're done. And so it's kind of an unexpected thing with the 4 next loop is that X actually ends up out of bounds when you're done with it. Now, you don't have to count only by 1. If I said step 1, that's the default. This will behave exactly the same. But I could count by 2s. So now I've got 1, 3, 5, 7, 9, and we go still to 11. But what if I stepped by 3? Would I end off at 11? No, I'm going to end off at 12. I thought I was going to end off at 12. Oh, wait, step 3. I ran the wrong one. Thank you. We end off at 13. Right. Because we're adding onto it 3 each time. So 1 plus 3 is 4, plus 3 is 7, plus 3 is 11. I'm sorry, plus 3 is 10, but we're still in bounds. And so we add 3 to that, and that's what lets us out of bounds. Questions? Yeah. Yes. So that's an important distinction here, is that I check the exit condition for the do loop. I check the exit condition every time. Because the for loop is saying, I'm going into this loop, I know how many times I have to iterate. It actually doesn't check the condition every time. It says, all right, I'm gonna go until X is larger than 10. Right? I could put some variable in here. And y as an integer, y equals 10. Do for x equals 1 to y. You see, that's the same thing so far, right? You see that. But what if I changed y inside the loop? Y equals 100. Is this going to execute? This would be a great question for the midterm. I don't think I'm going to put it on. Probably more than I would expect you to be ready for the midterm. But how many times is it going to execute? Is it going to execute until x is outside of the boundary of 100, or is it going to stick to the original 1? I am like 99, I'm like 5 nines, 99.999% confident this is still going to go just for that same range. It's going to stop way before x gets to 100. And that's because when we're setting up the loop, it checks this value, but it doesn't go back and check it each time like the do loop does. It says, I know how many times we're going into it. And so, oh, I really hope I'm right about that. Yeah, so it doesn't keep checking it. It says, so that's an important distinction. Do loop, it actually checks for each iteration. This one, the whole point is we're saying we know how many times we have to iterate. So even if my exit condition technically has changed inside the loop, it doesn't affect how many times it's going to iterate. Incidentally, you could modify x in here. That's okay. X equals x minus 1. That's not going to take me into an endless loop. If I was stepping by one, this would take me into an endless loop. I'd subtract one off of it, I'd add one to it, and X would never change. But since I'm stepping by 3, this will be a little bit different. I'm not entirely sure what this is going to print. 1, 3, 5, 7, 9, 11. So it's counting by 2s. Because I subtracted 1 the first time through, that's going to push this down to 0. We're going to add 3 onto it. Next time through will be coming through at 2. This is a really weird thing to do. Don't do it. Right? If you get the urge to do this, convert it over to a do loop. Write it as a do loop. The whole point of a for next loop says, I know how many times I'm going to iterate. It's really straightforward. Okay. Is there anything else? Oh yeah, there's one more thing about the do loop, and that is you can count backwards. You go from 10 to 1. And let's just go ahead and step 1. Let's not subtract that in the middle. By the way, because the for loop is really clear, it handles the incrementing itself, I typically don't put a do events into a for loop. It's really unusual to put yourself into an endless loop in a for loop. You can do it, but you got to manipulate the variable inside, like subtract 1 from it or something, or add 1 to it. Well, subtract 1. So that's why you don't see me putting the do events in here. Now, how many times is this going to iterate? It would be tempting for me to say that it's going to iterate 1 time, but I don't think it's going to iterate at all. It's not going to execute at all, because the upper boundary here is 1. And what is X going to start at? 10. It's going to start above the upper boundary. Oh, it's printing this one right here. But if I say, no, I want to count backwards, I want to step in a negative direction, then it says, oh, okay. So now we're counting down. So with a negative value here, it's going to loop until it's below this range. So that's going to count backwards. The one other thing that I want to point out with this is that let's suppose that I'm looping across like years. I've got to process a bunch of different years. It's a really normal thing to say I want X to go from 2017 to 2022. It's indifferent in terms of what integers it is, but if what I'm really looking for is X to be referring to a particular year, then that's the other thing I want to point out here, is that this is also a really common thing to do. I think that's still valid data towards the bottom. I don't know, maybe it'd be somewhere in the T's. How many T states do we have? Tennessee, Texas. Is that it, or is there more? Maybe a bunch more for all I know. Oh, I don't want to step 1. I want to step -1. I'll step 1, or I'll just get rid of the step altogether, which will step 1. Oh, the W's, a little bit further. Oh no, we're in the N's, North Carolina. What's that? Did I really? I don't think I did, but let's run it again anyway. Yeah, I knew I was on the right one because I was seeing what looked like years, even though these are referring to rows. So North Carolina. That's the for loop. Any other questions on the for loop? Anything I should tell them else about the for loop? Okay, let's look at extending this for loop to do something a little bit different. Let's suppose that I wanted to loop across all the sheets. Let me give me a few more worksheets in this workbook. I've got 5 worksheets now in this workbook. So now I'm going to do for X equals 1, 2, 5. And debug.print X, and then let me print off the names of these sheets. Worksheet. worksheet sub x dot name. Okay, remember worksheets is a built-in collection. It has all the worksheets in the current workbook. And so I can refer to them either by their name. So I could put a string in here referring to data and then sheet 3, sheet 4, et cetera, or their ordinal positions. So I can refer to it 1, 2, 3, 4, 5, which is what this is doing. So this should print 1, data, 2, sheet 3, and so forth. I'll run this. So 1, 2, 3, 4, 5, and it's printed off those 5. That syntax is not too bad. But it turns out that this is so common that there's a special loop just for doing this, saying I want to iterate across all of the elements of a collection. In fact, let's do one more thing to make this say, I mean, this isn't looping across all the elements of the collection. This is looping across the first 5 elements of the collection. If I want to do all of them, well, I'll just put something different here. What am I going to put here? Worksheets.count. I'll say, listen, I want to find out how many worksheets we've got. That's going to be the upper boundary. I'm going to start at 1, and that should go across. I've added a couple more now, I think. So we should get a few more listed here. And if I were to add more sheets and run the code, what can I do? If I were to add more sheets and run the code, of course, it would do all those sheets. Okay, so the loop that they made specifically for doing that is called a for each loop. Sub for each demo. The for each loop is really similar to the for loop, but I need to have a different kind of control variable. The for next loop takes an integer control variable. It can be byte, can be integer, can be long integer. Actually, I think it can be any numeric one. So I think this will work okay if we make it like single precision floating point number. But it's only going to ever put an integer value into it. Yeah, so that still works just fine. I'm pretty sure that I can't step like 1.5. I know that I can't. And so, but we use, these are always integers. Okay, the control variable for a for each loop is not an integer, it's an object. So dim sheet as object. Anyone want to remind me what an object variable is? An object is a thing. So an object is, you know, it's some complex structure that's got lots of properties. It might have methods, but it's something I can manipulate through code. An object variable is a variable that allocates just a small amount of memory, just enough to hold the address of some other location in memory. So here's the idea, is that if I'm talking about this range right here, D2, that range is somewhere in memory. I mean, it's like at a location in memory. The information about that range is somewhere in memory. And I can refer to this, if I can just get a reference to where that range is in memory. And there's lots of ways for me to get a reference to it. One is the range method. I could say range D2, and that would execute and say, oh yeah, you're talking about this range is at this location in memory. And it would say, here's the reference to that range. Saying the reference to the range is just saying another way of saying, here's the memory address, here's the location in memory where that object is. I can do it with cells. So this would be cells, row number 2, cells 2, 4. So row 2, column 4 would also refer to it. If I was to refer to it right now, active cell would also go find that address. So an object variable just says, hey, you went and found the address somewhere. It was a lot of work to find that address. I'm going to remember that address for you. So you don't have to go look it up again, and whatever method is looking it up, I'll just remember it. And so you can refer to that object by the object variable. Okay, so now I'm going to integrate this with a for loop. For each sheet, right? So here's the control variable. In worksheets, this is the collection, right? This is all the collection. This is all the worksheets in the current workbook, a currently active workbook. Next, And so what this does is it's going to say, all right, we are going to bind on this variable to the first element in this collection and then run the loop. And then we'll bind it on to the next element of the collection and run the loop. So I can just debug.print sheet.name, and that should print off the same set of sheet names. This is a lot to bite off. This is a kind of abstract thing. We're going to spend some more time on this. But let me back up into this other loop where we were showing this, and let me kind of do the same thing here. Let me dim sheet as an object. And then let me set sheet equal to this worksheet. Right, so in this example, we're iterating across these using an integer to refer to which sheet we are. So this time, instead of just printing worksheet X, I'm going to bind worksheet X onto sheet. So worksheets number 1, the first time through will be, this will find the memory address of that particular worksheet. It'll put it into this variable. So if I refer to it here, sheet, that should now do the same thing. So in this case, I've got an object variable here. I've got an integer variable here that I'm using to control the loop. I then use that integer to say, that's the worksheet that I want to bind on to this object variable. Right? This one goes and says, oh yeah, I know which worksheet you're talking about. It's located here in memory. It hands that memory address back. We hold it in the sheet variable, and then I can refer to that object using sheet. All that happens automatically in this. It's much simpler syntax. But you can see it's doing the same thing, right? I'm getting a reference to each object in that set as I go. Now, as long as it's the right kind of object, I could actually bind this onto a worksheet, a variable of type worksheet. So worksheet is an object variable, but as soon as I say, listen, it's going to be a worksheet, 2 things happen. 1, I'm not allowed to bind this variable onto anything that's not a worksheet. That's good, because that's all I want to do with it. But if I say sheet dot, then I get the IntelliSense help. And so usually it's a good idea, if you're only going to bind on one kind of object, it's a good idea to bind on to the, not just the type object, but the actual kind of object you're going to connect onto, just because it'll help you while you're programming. That's the biggest reason that I do it. Okay, what order is it going to go through these in? Well, this kind of depends on the collection. So here it's going to go through these sheets in the order that they appear, just as if we were counting up. Well, what if I want them to go, what if I want to process these backwards? What if instead of doing data sheet 3, sheet 4, I want to do sheet 2, sheet 7, sheet 6? If I care about the order that I'm going through, and it doesn't happen that the default order is going to work for me, then there's no change that I can make to the for each loop to do it. For each says, listen, I want to process every single element in this collection, but I don't get to say much about the order that I go through them in. If I want to go in backwards order, what would I do? I'd go back to the for loop and I'd do a step -1. I'd set it up to actually the index goes backwards and use that to refer to the elements in the set. Okay, let's look at another for each, because I know that this one's kind of tough to get a hold of. For each demo 2. This time, let's look for a particular range. So let me dim RNG, or let me dim cell as a range. For each cell in, why don't we say our sheet called county dot used range. Used range is the smallest rectangle that contains all the data on the worksheet. And so now I'm going to iterate across every single cell in the in the used range. Now that's not every cell with data, that's every cell in the used range. Those will be the same in this one because it happens that every cell in the used range has data in it. But we'll change that here in just a second. Next. Debug.print cell.address cell.value. So this is gonna print a lot. I'm gonna do do events in this so I can interrupt it. It happens that when you're iterating across the elements of a range, it's going to go rows first and then columns. And so the very first one that I'm going to do is going to be A1, then it'll do B1, then C1, and then come across this way. It probably happened too fast for us to see. So maybe we'll slow it down. Yeah, a little too fast. Well, I don't know. You can see that it's changing quickly between A, B, and C. Here, can you see it on that screen too? Yeah. So we're only to the Georgias yet. So, by the way, if you're fortunate enough to have a break key on your keyboard, you can hit Control Break, and that will break. Otherwise, hit the pause button in there. So we can see here it's doing A, so it's doing all the rows of 709, and it's going on to 710. Show me on a scale of 0 to 5 how comfortable you are with the for each loop. 5, 5, 5, 5, 4, 5. Huh. Man, it took me a long time to really grasp this. I've seen somebody there at 1s and 2s. That's how I felt for the first quite a bit when I was trying to understand this loop, this kind of loop. But the trick is really understanding that this object variable, one at a time, is going to get connected up to one element in whatever set this is here. Run the loop. It'll connect onto the next one and run the loop. Connect onto the next one and run the loop. Any questions for this loop? Yeah. Can I dim a row as a range? Okay, so I could, yeah, instead of iterating across ranges, I'll iterate across rows. Yeah, I'm just going to change. Well, let me go ahead and make that another demonstration. It'll be maybe a little bit different than you expect. I don't really know what you expect, but let's call this 3. And instead of calling this cell, let me call this RNG. We dim row as a range for each row in use. So I'm still going to narrow this down to just the worksheet or just the cells that have data, but I'm going to iterate over the set of rows. So rows is a collection of the rows in that range. So there should be one for every row here. So now if I print row.address, it should print like A1 through C1 the first time. And it doesn't make any sense to do row.value because there's going to be 3 values. So let me say row.cells sub1 dot value. And then we'll do 2 and 3. I'm not entirely sure that'll work. Let's give it a shot. And break. So now we're connecting on to that same used range, but instead of going cell by cell, we're going row by row. So it happens that rows is a collection of the rows in whatever range I'm specifying. Now, might be an interesting opportunity for us to kind of do a nested loop. So instead of printing these out 1, 2, 3, you stop this loop. I'll leave the comma on the end here. And I'll do a for loop. Declare a variable to control this. Dim call as an integer. Only 16,000 columns on a worksheet, and so integer will be fine for referring to columns. For call equals 1, 2. Now in this case, I know that there's only 3, but the next time I run this, there could be more than 3 columns. I want to print them all. So instead of going to 3 here, I'm going to say I want to go to row.cells.count. That'll tell me how many cells there are on that row. Debug.print row.cells column. This comma, by the way, says don't put a carriage return at the end of this. Don't enter down to the next line, just tab. So I'm trying to get something that looks the same as this. And so because the last time through this loop, it's not going to do the carriage return. I'm going to have one more debug.print after the loop, which will give me the blank line. I don't have to put anything after debug.print will give me a blank line. And so I think this will give us the same thing. So the difference is that I now have a loop inside the loop. So one loop is going across the rows. The other loop is going across the columns. For each row that I get to, I'm going across all the columns. Go to the next row, go across the columns. Whew. Questions? What if I wanted to do all the cells one at a time, but instead of going across the rows, go across the first row, then go down, across the next row, go down. What if I want to go down the first column and then over? Oh, let's do a for each loop for that one as well. For each demo 4. Good heavens, 4. Okay, so in this case, I'm going to basically do the same thing that we had, but I'm going to change it the other way around. I'm going to make column a range and row as an integer. So this will now be for each call in used range columns. And we'll go ahead and print out the address. And here we'll say for row equals 1 to call dot cells dot count. Debug.print call dot cells sub row. So again, we're looking at our sheet, the used range, but instead of iterating across the set of rows that are in that used range, we're going to iterate across the set of columns that is in that. We'll print out, there are only 3, so we'll print off the address. And then we're going to go in that column, that first column, we're going to go through every row in that column. And so we now have an integer variable row that's going to start at 1 and go to however many cells there are in that column. We'll print that off, and that is going to print really wide. So instead of because it'll be like 3,000 columns wide. So I'm going to take this off and it'll just print them all into one column. For each call, COLUMNS, call, oh, it shouldn't be range, it should be range. Oh, I have do events, but where's the do events? It's outside that inner loop, so I can't interrupt this loop until it finishes. So it made it down here to, oh, that must be the, yeah, that's the number that we're dealing with. Get down to 32,000, 3,000 rows down. So it probably would make more sense to put this do events on the inner loop. And I think I want to print the address as well as the value. Okay, I don't know if you noticed, but initially I was just printing this. How did it know which property I meant? I said print this column, a particular cell out of that column, but I didn't say dot address or dot value. Why was it printing the value from column 1? The answer is, Excel says, the VBA interpreter says, listen, if you refer to a range and you use it in a way that I'm expecting to see a property used, and you didn't tell me the property, I'm going to think you probably meant the value. It's probably what you meant. And so that's what it's going to show. Okay, so now if I run this, it should show, yeah, so you can see it's counting down column A. And once it gets all the way down to 3,274, it'll pop over to column B and then go through those. So we've kind of forced this to go by down the first column, then over down the next column, which is not the native way that Excel wants to iterate across the range. Any other questions on this or other loops? How could it be that I'm done saying everything I wanted to say and more, and there's still 15 minutes left to go in the class? What have I forgotten? There is a homework assignment. Should we just do the homework right now? Yeah, we're not doing that. But I would entertain if you had general questions on the homework. We could take a look at that. Yeah, so let me break here. Hold on just a minute. Yeah. Sure. Okay. So you're doing the first 50 Fibonacci numbers. First thing I want to point out on this assignment is that you don't need any variables to do this. The thing that makes this a little bit difficult is that kind of the natural way, if you were to record yourself getting started with this, you're going to be like putting in a couple of values, which always records you selecting something and then changing it. And another additional constraint that I've given you on this homework assignment is that you're not allowed to select anything. The active cell can never change from where it is. So if I start this, right here on D3255, then it's got to stay. The active cell can't move from here. And so what method is going to be really helpful? So range object has lots of methods. What method is going to be really helpful to allow me to refer to a different cell? Yeah, the offset range or the offset method. So we could just say active cell dot offset 1 dot value equals, let's do this. let me put the first two numbers in here, 0 and 1. I'm going to leave the active cell right there. So what I have to do is I have to put in, how many more do I need for this sequence? I need 48 more for this sequence. And in fact, I'm going to offset from the active cell. I'm going to offset the first time. I'm going to offset 2 to get there, right? Let's write what that line would look like. So offset 2 from the active cell. That value is going to take on a new one. What's it going to be? It's going to be from the active cell offsetting 0 plus the active cell offsetting 1. Right? So I'm saying look at a cell 2 below my active cell, make a new value of it. What's the value going to be? It's going to be whatever is offset 1 from whatever is offset 0. I've got to run that line. And then I've got to run a line that looks like offset 3. It's going to look here at 2. Whoops, this should be 0. And offset 1. What's the next one look like? Offset 4, 3, 2. I got to do that 48 times. I got to get the first 2 in place. I got to do that 48 times. You want to know a secret about the grader? If you actually wrote that out 48 times, like copy and paste and changed it, it would have no idea you didn't use a loop. Yeah, it never looks at your code. It just looks at what your code does. Don't do that. But tell me, from what we've talked about in class today, you've got to get a number to go across a range, 2 to 50. How would you do it? What kind of loop would you use to do that? This is the 4 next loop. It's hardwired for that. And once I've got this one, let's say that's going to be a variable, it'll be my variable x that's I'm using to control the loop. If that's 2, then what expression based on x will give me this? Yeah, this is x minus 1, and this one is x minus. And if I could get that line to execute 50 times, I'd be in good shape. Well, 48 times. The trouble, if you decide I want to put that value into a variable and then use the variables to change, is that the first 50 Fibonacci numbers get big. They overrun the boundary that you can use for a long integer. So it's above 2 billion. It's like 2.9 billion is the 50th. Well, maybe it's the 47th Fibonacci number, which is the one that you run into an error on. It's outside the precision of what a single precision floating point number would be. And so if you really are intent on using a variable involved in this, you probably should use a double precision floating point number. That's going to have enough precision to get you through. Enough scope and precision. Okay. Other questions? Yes. Oh. Anytime you see an ordered pair in Excel, in VBA, where you're getting like a row and a column, it is always row first, and then it's always row and then column. And the column is optional. So if you don't specify the column, it assumes 0. Well, it doesn't assume 0, it asserts 0. So right, since you're staying in the same column, you don't need the second argument for how many cells you're going to offset. Yeah, functions often have a default value that if you don't provide a value for it, it'll assume something. It'll just say, oh, if you didn't give me a number there, I'm going to assume 0. Other questions? Well, after having like a week off, maybe we should be easing back into this anyway. So let's call it good there for today. And I will see you on Wednesday. Class dismissed.